Section 8 is unions and intersections of sets. We're going to try to finish off the section today and also finish the chapter because this is the last section of the chapter. So we have a little bit of vocabulary we have to learn here because this is probably brand new stuff to you. Well, maybe not entirely brand new, but mostly brand new, especially this vocabulary. We have union, intersection, and disjoint sets. The union, I'm just going to give you the definitions right now, is every element in every set put together. So like the union of the students in this room and the students in Mr. Hanlon's room would be like the names of all of you and the names of all of the students who are in Mr. Hanlon's room right now put together on one list. Okay? We're taking everything and just putting it together. If I take everything and put together, that's like saying or. I'm going to select a student from this room or from Mr. Hanlon's room. So all of the names from the students who are in this room and all of the names from the students who are in Mr. Hanlon's room go into a hat. I reach into the hat and I pull out a name. Okay? This room or Mr. Hanlon's room. Everybody got put in the hat. The intersection is every repeated element in sets. So now I'm going to take only the students who have me and Mr. Hanlon both and put them in a hat. Obviously everybody in this room has me. How many of you have Mr. Hanlon? So in that case then only your names are going to go in that hat. Okay? You see how that works? The intersection is repeated values. If I'm drawing repeated values on a number line, I see a region of overlap. And regions of overlap occur when we have what kind of statements? And. Intersections are and statements. Disjoint sets are sets that have nothing in common. It'd be like trying to compare the people in this room to elephants. They don't have anything in common. They're both animals, I guess, but elephants aren't in school. So those would be disjoint sets. They have absolutely nothing in common. We use sets when we're dealing with Venn diagrams. So in this section, we're going to see Venn diagrams quite a bit. Hopefully you remember what those are. All right, so let's go on. First, we're going to talk about unions. Unions are all of the elements in all of the sets. In a Venn diagram, the union would be everything inside the sets A and B. So remember this letter U. U stands for the universal set. Everything that there is. Okay? All of the students in Grable High School would be the universal set. Maybe set A would be the number or the students, all the students who have me as a teacher. Maybe set B would be all of the students who have Mr. Hanlon as a teacher. Okay? Now the union is everybody in those two sets. So the union is actually all of these people and also all of these people. Is that everybody in the school? No, I don't have every student and neither does Mr. Hanlon. Okay? So there are students outside of this that don't qualify at all. But anybody who has me or anybody who has Mr. Hanlon is going to be involved in this union. There's a notation right here. That giant U-looking shape actually is a U. It stands for union. So notice the symbol for union. It's a big capital U. Make it look bigger than your normal capital U's. Notice that this one kind of looks pretty wide right here. Wider than a normal capital U. So make this a little bit wider, like the Miami Hurricanes U, if you know what I'm talking about. Some of you do. Okay, in your left pocket, so here's a different example. In your left pocket, you have a quarter, a paper clip, and a key. That sounds like my typical left pocket. In your right pocket, you have a penny, a quarter, a pencil, and a marble. Excellent assortment of stuff in your pocket. What is a set that represents the different items in your pockets? What I'm asking for here is, what is in both of your pockets? This is a union. Okay? So I can write up here, by the way, that would be A union B. You don't have to make your U that big, but it needs to be bigger. Down here, I'm talking about the left pocket, so left union with the right. The left pocket union with the right pocket. So I'm just taking everything that's in the left pocket and everything that's in the right pocket, and I'm dumping them out on the table, and I'm saying, what do I got? Okay? What is left union right? Well, let's call it something. Pick a letter. For a set, we usually go with A. So we'll go with capital A equals, this is a set of stuff, so we open a squiggly bracket, and then we just list stuff. List the things that were in each pocket. Well, in the left pocket, we have a quarter, paper clip, key. In the right pocket, we have penny, and then we also have a quarter in the right pocket. And I already wrote quarter down, so I don't need to write it down again. I don't write repeated stuff in my sets. But I do have a pencil, and of course a marble. Everybody has at least one marble in their pocket. And that's it. Okay, so that's the set that represents the union of those two things. Okay, write sets P and Q below in roster form. We know that roster form means what? The baseball roster does what? Everybody's listed out. So roster form means list everything out, okay? So we have two sets. Write them in roster form first, then find the union, P union Q. By the way, you don't read that as a U, you say union. And you don't try to say it like a word. This isn't puke. This is P union Q, okay? P is X such that X is a whole number less than 5. Whole numbers less than 5. So we need to remember what whole numbers are. What are whole numbers? The counting numbers and 0. So P equals, in roster form, where do I start? At 0. And I'm going to go all the way to what? 4. Because it says a whole number less than 5. So we can't include 5. We have to stop at 4. Okay, so that's P. Let's take a look at Q. Q says Y such that Y is an even natural number less than 5. An even natural number. Well, what's a natural number? The counting numbers. Is that including 0? No. Okay, what's an even number? 2, 4, and so on. Okay, now less than 5. So I open up my set notation here. Where am I starting? 2. What's my next one? 4. What's my next one? That's it. Because 6 would be the next one. And 6 is greater than 5, so 6 is not part of this set. So now that we know what all the elements in both of these sets are, we can make P union Q. So I'm going to write P union Q equals, and I'm just going to write it in roster form. P union Q takes all of the elements in both sets and puts them together. We don't write the repeats though. So if I start by writing P down, I have 0, I have 1, I have 2, and I have a 2 down here in Q, so I don't have to worry about writing that again. I have a 3, I have a 4, and I have a 4 down here in Q, so I don't have to worry about writing that one again. I've written down all of the P's, and I also already wrote down all the Q's, so I close the squiggly bracket there, and I'm done. That's P union Q. So let's move on to intersections. Intersections involve only the shared elements between sets. Think of the intersection of a road. This is how I remember how or what an intersection is. I'm going to draw a little road diagram up here. It's going to be fantastic. And maybe some dotted lines. This is an intersection for a road. Agreed? Okay. The intersection is the shared part. Every time you have an intersection for a road, this road continues on in this direction, this road continues on in this direction, but at the intersection, we have a shared portion. This shared portion here is shared by this road and this road. That's what an intersection is in our life, and that's exactly the same as the intersection in math. The intersection is only the shared stuff. So my example from earlier was me and Mr. Hanlon. Here's all of the students in Graybull High School. Here's all of the students in Graybull High School who have me as a teacher. And then this would be all of the students in Graybull High School who have Mr. Hanlon as a teacher. This little portion in between would be all of the students in Graybull High School who have both me and Mr. Hanlon as a teacher. That's the intersection, the overlapped area. The symbol for intersection is sitting right here. We have the intersection of A and B. A intersect B. And notice what the symbol is. What is it? It's the upside down U. So instead of a right side up big U, capital U, it's an upside down big capital U. Okay? On a Venn diagram, the intersection is the overlapping region. That's this guy right here. Notice the symbol for intersection is just a giant upside down capital U. So then you'd write A intersect B. That's the mathematical symbol for intersection. Disjoint sets have no intersection, which means there are no shared elements. And the example I have of that is, again, the universal set. So all of these students here in this Venn diagram are students in Graybull High School. These are all of the students who have me as a teacher. And then these would be all the students who have Mrs. Cheatham, the other math teacher, as a teacher. If you have me, you don't have her. If you have her, you don't have me. Right? That's pretty universally true. So these are all my students. These are all her students. Nobody has both of us, so there is no overlap here. These are disjoint sets. A and B are disjoint. There's no notation for that. We just say disjoint. So here are a couple examples. We have 3 sets in this first example. Set X equals that stuff, set Y equals that stuff, set Z equals that stuff. And then we're asked, what is X, what? Intersect Z. And then we're asked, what is Y intersect Z? Okay? So with intersection, we are looking for shared elements, repeated stuff in all the sets. Okay? So with X, Y, and Z, let's write out roster form here so we can figure out what these elements are. What is going to be roster form for set capital X? We have X as a natural number, less than 19. 1 through 18. So I'm going to write 1, 2, 3, and then I'm going to put dot, 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 because I don't want to sit here and write all that out. 17, comma, 18. All right, and I'm just understanding that all the counting numbers between 1 and 18 are there. Okay, set Y is an odd integer. Odd integer. What are the integers? Integers are all whole numbers and their opposites, yeah. No fractions, no decimals. And we're only looking at the odd integers here. So rather than writing -3, -2, -1, 0, 1, 2, 3, I'm going to write ... because that goes on forever in both directions. -3, and then my next number would be, nope, because I'm looking at odd integers, -1, and my next number would be normally 0, but I'm skipping 0 and going to 1, and then my next number would be 3, and I can continue on from there, okay? I write down enough so that I understand what that set actually is. There's no way I can write down all of the numbers in that set in roster form because there's an infinite amount of them in both directions. Now the last one, set Z. Z is a multiple of 6. So what are some multiples of 6? How do I get multiples of 6? So I could do like 6 times 1, which is, I could do 6 times 2, which is, and then 6 times 3, which is, but I could also go with negative numbers, and I could also multiply 6 times 0. Those are all multiples of 6, those results, okay? So if I take, I'll just look at this since I have it written down right here. If I take -3 and I multiply it by 6, what do I get? -18. So I could also go -4, and I could go -5 and -6 times 6 each time. So I'm going ... -18, comma. Now I go -2 times 6. What is that? -12. And then -1, or -1 times 6, which is -6, and then continue on. What's the next one? 0, and then 6, and then 12, and then 18, and then it continues on for forever. Okay, now that I have these written out in roster form, or at least as best as I can, because I can't write all these numbers down with infinite sets, we want x intersect with z, which means I want to look at the sets x and z and decide what numbers are overlapping, what numbers are being repeated by both sets. So here's x on top, here's z on the bottom. Which numbers are being repeated? Because I didn't start at 0, I started at 1. So I have 6 in this set, I have 18 in this set, is that it? Also 12. So I'm going to write x intersect z equals, this is a set, so I use squiggly brackets, 6, 12, and 18. Just close the squiggly brackets and you're done. That's the answer. Okay, how about y intersect z? Nothing? Why not? Yeah, 6 is an even number, and all of these multiples that we have in set z are even. All of the numbers that we have in set y are odd. Are we ever going to have a repeated number? No. So my answer here is capital Y intersect z equals, it is a set that has nothing in it, which means it's the empty set. So you put the symbol for empty set down. You can have nothing. So in other words, with the empty set, these two sets are, what's our vocab word that we just learned? There's no overlap. They are disjoint. So when you have disjoint sets, the intersection is going to be the empty set. Okay, let A equal 2, 4, 6, 8. Let B equal 0, 2, 5, 7, 8. And then let C equal an odd whole number. Odd whole number. What's an odd whole number? Where do we start? 1, 3, 7, 9, and so on. Okay? A whole number starts at 0, but the odd ones then would start at 1. So 1, 3, 5, 7, 9, and so on. Okay, A intersect B. I'm going to write A intersect B equals, open a squiggly bracket. What do I have? 2 for sure. Anything else? 8. Anything else? And that's it. The easiest way to do that is to just pick one set and say, okay, I got a 2 there, I got a 2 there, so 2. 4 there, no 4 there, so that one doesn't work. 6 there, no 6 there, so that one doesn't work. 8 there, 8 there, so that one works. And now I've looked at every single one in this set, which means I'm done. Okay, A intersect C. So I'm going to write A intersect C equals, open a squiggly bracket, and what do we have? They're disjoint again because these are all even numbers here, and these are all odd numbers. So there is nothing. It's the empty set. Then finally, C intersect B. So I'm going to write C intersect B equals, squiggly bracket, what do we got? 5. Anything else? 7. Anything else? That's it. So at this point, you can do 10 through 22 on the homework assignment. It is all of them, so make sure you make a note of that. Don't just do odds on that. And we're going to move on. Making Venn diagrams. You should have done this before at some point in your school career. Made a Venn diagram. So we're going to remember how to do that, and if you haven't done it before, well, then you're going to learn it now. We want to create an inventory of all of the items in the backpacks. And in your notes, you can't really see very well what's going on in those backpacks. Up here, you can kind of see a little bit better. It says 3 friends are going camping. The items in each of their backpacks form a set. Which items do all 3 friends have in common? Here's how you're going to do this. Make a list. Make a roster form for each backpack. Okay? If this was your backpack, this yellow backpack here, you would make a list of all the items that you had in your backpack. And so would this person, and so would this person. And then you'd compare the lists. Okay? That's exactly what we're doing here. So we have the yellow backpack. What's in it? So sunglasses. What else? Huh? Okay, water right here. Yep. Probably pretty smart. What else? There's a map. Good. What else? Looks like a hat right here. Good. Yeah, that looks like a pan to me right there too, so pan. What else? There's a flashlight right there. Anything else? That's it. This thing right here is the handle to the pan. Okay? So that's yellow. How about blue? Water. What else? Camera. Hat. Looks like a map. Anything else? That is a first aid kit, all the way in the back inside here. So first aid. Okay, anything else? Okay, that's it. And then the red backpack, what do we have? Water again. Hat. Pan. First aid. Looks like a rope. Is that it? Map. That's it. So now we have roster form for all three of those backpacks. We want to make a Venn diagram. The Venn diagram has to have overlapping regions because obviously we have shared things. But there's 3 backpacks. So if I had just 2 backpacks, I would draw a circle and a circle. But I have 3 backpacks. So I have to draw a third circle in such a way that I can have shared stuff between just this one and the third circle, just this one and the third circle, but then shared stuff between all 3. So that's why my circle has to look like this. It's an awesome circle. But it does have stuff that's by itself. It has stuff that's shared here. It has stuff that's shared by both. It has stuff that's shared here. Now label these so that we know which one's which. I'll call this one yellow. This one's blue. And then the bottom one here will be red. Now we want to put stuff in the correct locations. So what I do is I start with my first list, yellow, and I'm going to pick that first item, sunglasses, and I'm going to look to see if there's sunglasses in any of these other backpacks. And there aren't. So that means that sunglasses is only in the yellow backpack, so I'm putting sunglasses in only the yellow portion of the Venn diagram, and then I'm going to check it off. Done. Now I'm going to go to water. Is water in any other backpack besides yellow? Yes. We got water there, we got water there, we got water there. So water is in all 3, which means I need to put it in the region that holds all 3. So water goes here. And I'm going to cross it off. Done, done, done. Go on to the map in the yellow. Is the map anywhere else? Where? It's in blue. Anywhere else? It's also in red. So it's actually in all 3. So where's that one going? By the water in the middle. Map. Cross it off. Done, done, done. How about the hat? Hat's in all 3. So I put the hat here and cross it off. Done, done, done. How about the pan? Just yellow and red. So I need to find where yellow and red only is. Here's yellow. Here's red. This is all 3. This is just yellow and red. So I put the pan there. And I cross them off. Done there, done there. How about flashlight? Just yellow. Okay, and that takes care of the yellow backpack. So now I'll move on to blue. And remaining on blue is the camera. Is the camera anywhere else? No, so I put camera in just blue. And cross it off. And then I have first aid. Is the first aid anywhere else? Yep, it's also in red, so I go to the region shared by blue and red, and I write first aid. Cross it off there and there. That takes care of all the items in blue. All I'm left with now is the items that are just in red, and that would be the rope. So I put rope here, and I'm finished. That's how you do a Venn diagram. We want to make a Venn diagram that models these 3 sets. So now I'm not giving you a backpack with pictures, I'm giving you set builder notation. So let's take a look at set A. In roster form, it says X is one of the first 5 letters of the alphabet. Well, we can come up with that pretty easily. So in roster form, set A is what? A, B, C, D, E. First 5 letters of the alphabet. Easy enough. Set B says X is a vowel. Well, that's also pretty easy. In roster form, B is going to be what? A, E, I, O, U. And finally, for set C, X is a letter in the word vegetable. So I'm going to write C, roster form. What's a letter in the word vegetable? V, E, then G, then. So E was already written down. I'm not going to write it again. T, A, B, L. And again, E was already written down. So those are the letters in set C. The directions say make a Venn diagram. How many circles do I need? 3. So I'll draw my 3 circles, making sure I have overlap for all 3. Now what? Yeah, you want to label these. So I have set A, capital A. I have set B and set C. Make sure you label them, otherwise we don't know what you're doing, and really neither do you. Okay, now what? Start putting stuff in spots. So I'm going to start with set A, and in set A my first letter is A. Do I have A anywhere else? Actually all 3. So A goes dead center, and I'm going to cross off A. Go to B. B is in A and C. So I put that in A and C, which is this guy, B. Cross it off. Next letter, C. Just in A, so I put it here, cross it off. Next letter, D. Just in A, so I put the D there, and I cross it off. And E. All 3, so I put the E here, and I cross it off. And that takes care of set A, so I move on to set B. Next letter that I haven't crossed off yet is I. Where does it go? Just in B, kind of like Justin Bieber. And next, also Justin Bieber. And then, there you go. And then all we have left is all these letters in set C, which means they all just go in set C. So V, G, T, L. And you're done. Okay, another Venn diagram problem. It says of 500 commuters pulled. Do you guys know what commuters are? What are they? People who go back and forth to work. So like Mr. Heinemeyer lives in Worland, he commutes to Grayville every day. That's what a commuter is. In big cities, pretty much everybody's a commuter unless they live like right next door or in the same building as where they work. Okay? They travel in from other cities, they take buses, they take cars, they ride bikes, they walk, they take subways, they take trains. Some people fly to work. Of 500 commuters polled, so we surveyed 500 people. Some drive to work, some take public transportation. Public transportation would be a bus or a train, a subway, something like that. Some do both. 200 commuters drive to work and 125 use both types of transportation. How many commuters take public transportation? You cannot answer this problem very easily without a Venn diagram. A Venn diagram makes this problem really simple. So I'll make a Venn diagram. Well, how many different things are we talking about here? We have some people driving to work, and some take public transportation, and some do both. How many circles do I need? 2. And I have to have overlap because some people do both. Okay? Now what are these 2 circles? What's the left one? Drive, yeah. People who drive to work. What's the other one? Public transportation. I'm just going to abbreviate that PT. Now they give us some information here. It says, how many people drive? No. It says 200 people drive to work. But I have this Venn diagram here. This has 200 people in it. But I don't know how many people are here. and I don't know how many people are here. Okay? So it comes from the other piece of information. It says 125 people use both types of transportation. So where does that 125 go for sure? Yeah, there are 125 people here using both types of transportation. So how many people are there in this circle for driving? It says 200 commuters drive to work. So that means there's 200 people in this circle. And if 125 of those 200 people are in this part, then there's 75 people over here who drive only. Of 500 commuters polled, we have one more thing to fill in here. I got 500 people total that need to be in this diagram. Right now, how many people do I have in this diagram? 200. So how many people go over here? 300. And that's the Venn diagram. Okay, you had to kind of reason your way through it. You can't just enter numbers in. Put the numbers in the correct spots that you know for sure, and then come up with the missing stuff. So, what does the intersection represent? Where is the intersection? The stuff in the middle, 125. What does that represent? Number of people who do both. How many people only drive? 75. We had to figure that out to be able to make the Venn diagram. How many only use public transportation? 300. See how easy the problem becomes once you have a Venn diagram? If you didn't draw that Venn diagram, you probably would get questions 3 and 4 wrong. All right. We have one last thing we need to do in this section. We're going to solve the inequality. So these are absolute value inequalities. This takes us back to the previous section. Write your answers in these notations. We have set builder notation, but now as a union or intersection. So we remember in the beginning when I taught you what union and intersection were, I told you that union acts like a marriage. What word though? And or. Union acts like or, and intersection acts like and. So we are going to use these symbols now instead of writing the words and or. Also write your answers using interval notation. So here we go. This is kind of a review of the last section, which actually takes everything that we did in this entire chapter and throws it all together on these 3 problems. It makes it very beautiful. So, what? Are these on the test? You better believe it, because these prove that you know exactly what was going on in this entire chapter. Terrible. If you can get all these right, then you should be able to get everything right. All right, so what are we going to do on that first one? Yeah, anytime you have absolute value, get the absolute value by itself, and then do case 1 and case 2. So case 1 and case 2. What's case 1? Yep, the whole thing. 2x minus 1 is less than 3. What's case 2? 2x minus 1 is greater than negative 3. And then we can also squeeze a word in there. This is an absolute value inequality. It says less than. It's an and statement. So I'm going to write the word and here for now. Okay, solve case 1. What do we do? Add 1 to both sides. 2x is less than 4. Now what? How about divide both sides by 2? X is less than 2. And solve case 2. Add 1 to both sides. Greater than negative 2. Now divide both sides by 2. X. Good. So now that is our answer. But they said write your answers in set builder notation as a union or intersection. So instead of writing and, I have to write a symbol. What symbol do I have to write? Is it the U or is it the upside down U? It's the upside down U. And is an intersection. So I'm going to write squiggly bracket x values such that x is less than 2 intersection with upside down U, x is greater than -1. So that is your set builder notation now. Which is awesome because you could show that to your little brother or your little sister and they'd be like, I have no idea what that means, algebra is scary. And you'd laugh and say, actually, algebra is not scary, this is kind of easy. Nope, and is intersection. Intersection is the upside down U. Union is the OR. Okay, so that takes care of set builder notation, but we also need to write our answer using interval notation. Interval notation is going to be easier to write if we graph it, so let's graph it. We have -1 and +2. Open dots. We have greater than -1. We have less than +2, so it winds up looking like that. An AND statement. Now it's easy to come up with interval notation. Open dot means what? Parentheses, -1 to 2 and parentheses. That's it. Okay, middle one. What kind of statement is this guy? I don't see a word here. It's an AND statement. The variable is squished between two numbers on the outside. This is an AND statement. It's going to look just like this one here. So how do I solve this in one move? Subtract 5 from all three parts. Yep. -5, -5, -5, and what do I get? Less than 6. So that is your answer. We need to put that in set builder notation. Very easy to do that. There's no need for the union or intersection symbol there because we haven't written a word down. So that's the set builder notation. Now we need to graph it so that we can write interval notation. 3 and 6. X is somewhere between. Can we include 3 or no? Yes, so that's a solid dot. Can we include 6 or no? Nope, so that's an open dot. And X can be anywhere between. There you go. So now interval notation is bracket 3, comma, 6, parentheses. And the last one. What are we doing first here? Case 1 and case 2. It's absolute value, inequality. Anytime you see absolute value symbols, you have to go case 1 and case 2. Case 1 is what? Everything stays the same. Case 2 is what? Flip the inequality symbol and change the sign of the answer. Okay, case 1. Now we can add 6 to both sides and we have 4x is greater than 20. So now we divide both sides by 4. X is greater than 5. By the way, what word is going on here? It's an OR statement. With this greater than symbol here, this is an OR. So I'm going to bring down the OR. Case 2, what do? Add 6 to both sides. And that's 4x is less than what? -8. Divide both sides by 4. X is less than -2. Okay, set builder notation using intersection or union symbols. So we have squiggly bracket x such that x is greater than 5, what symbol? Union. X is less than -2. Draw the graph to help with the interval notation. Bell's going to ring here, just hang on. We have -2 and 5. Both are open and they're going outward. So the interval notation here will be parentheses -infinity, comma -2, parentheses. Then you can use the union symbol again. Union, open parentheses, 5, comma, positive infinity, close parentheses. So the union and intersection symbols work for both.